All right, my name is Eding. I'm an engineering manager here at WMLSWUG. For the past 10 years, I did the sheet metal enclosures on our equipment, and prior to that, I worked at Holland Sheet Metal Job Shop, where I was the engineer there. We were anywhere from 5 to 15 employees, so I got to design all the stuff and a lot of hands-on experience making my own parts. So I'm very familiar with the press brake and the shear and the bandsaw, whatever it takes to make the part. And if you ever have to make a part from your own drawing, it doesn't take you long to figure out what a good drawing is versus what a bad drawing is. You just develop that. And you strip it of all the unnecessary information, and you just put on it what you need. So today is going to be on, I call it practical sheet metal or basic sheet metal. So if you're very well versed in it, I don't know that I have much to offer, but we'll look at it anyway. The command set in SolidWorks, from my perspective, is ideal for a laser cut part that's brake press formed, and that's predominantly what the features center around. The features are capable of generating, I'd call it's the flat planar part. They're capable of generating a round or a radius part, that or one like this. They're capable of generating a conical part, and this one here is just a free-form part using the loft. The challenge with it, once you use a free-form part using the loft, is there's really no planar surfaces on it anymore, so you can't really do much with it other than maybe pop a hole through it, using one of the front planes or right planes or top planes. You're kind of limited. If you can work around it and make your shape using, there's a planar surface, a conical surface, and a round surface, it leaves you a lot more freedom in the future for what you want to do with the part. I'm going to start with a new part. I want it to be a sheet metal part. So almost all the commands are grayed out. It leaves you with this one in the corner, which is base flange / tab. So it's actually two commands. You're either going to create the base flange or the starting point of your sheet metal part, where you're looking to add on to it by adding a tab to it. A tab is just some more flat metal. If you need to add some flat somewhere, then you would use that tab portion of the command. But you just simply start. I'll pick the top plane and I'll pick a sketch, and I'm just going to sketch something. If you want a sheet metal part, you can sketch it, put your dimensions on it. If you want holes in it, you put your holes in it. If you want other features in it, you put your features in it. If you have a completely enclosed sketch, you're going to wind up with, get it here. I'm going to pick a gauge. You're just going to wind up with that. It's just a nothing part. Whatever you draw is what you get. It's going to be one metal thickness, and it's going to have features above it and features below it that are related to the sheet metal properties and how it's bent up. And that command actually, yes, the command actually is identical to the command in the regular features for just a basic extruded command. I can do the same thing there, and I can pick go 60 thousandths, and I have the exact same part. It just doesn't have the sheet metal parameters attached to it that came from the gauge table. If I back off from that, so if my part is predominantly flat with maybe a bend here or that, I would start with a closed-in sketch. If your part is not predominantly flat, you can start with the shape that you would see as you stood down the side of the press brake. And if I see something there that's a couple inches two by 6 is fine. I could draw my shape. Now, if I were to attach that to the regular extruded boss, it would default to a thin feature, and it would give me, let me pick the thickness. I say 60, and I want to an autofill it, and again I say there's 60, and I want blind 12 inches. I get this part as if it looks like it's press brake form. It has a 60,000th inside radius, a 60,000th stick. So it's a command we should all be used to if we use the SolidWorks features. But the base, if I want the sheet metal properties, I can take the exact same shape and I attach it to the sheet metal. I do the same thing and say 12. Use a gauge table and say 16 gauge. And I'm set up with all the same geometry, all the same shape, except it adds this folder at the top and a flat pattern at the bottom. So the command is no different than the one we find here. It just adds other features. If I look at what I selected a gauge table. I picked 16 gauge. When I pick 16 gauge, it's an Excel spreadsheet that gets information off from it. The spreadsheet has on it, this typing of 16 gauge. It has on it an inside radius of 60,000 and has on it a K factor of 0.39. So it's things that we figured out a long time ago. We set it up in a spreadsheet, so we don't have to figure it out every time. We just go click the gauge table and away we go.
Are you using a different K factor for every gauge?
I'm using a different K factor for every gauge. And I can use, if I want, I can use a different K factor for more than one every radius. If I got a 16 gauge, I have a 16th inch radius, I use one K factor. If I have an 1/8 inch radius, I use a different K factor. And we all understand what a K factor is?
Locate your center point.
It locates what we call the neutral axis.
Yeah, zero stress.
If I look at, where's my K factors? So my K factors, here's the spreadsheets form. If I open up that 16 gauge, it's got my information in there. It's like, it looked like that because that's where I put it. It made the thickness 60 thousandths because that's what I said. It made the radius 60 thousandths because that's what I said. I change any one of those and it'll show up in my part according to what I have here. And if I have, here's my K factor I put in. If I use two different radiuses, I can just save this spreadsheet as another one. I can say, 16 gauge R.12, and it has a different K factor in it, and it has a different radius in here, whatever I want. So I can have several K factors for the same metal thickness, but it all depends on what my tooling gives me when I bend it up.
So you're measuring it from the tool on site and you determine the K factor?
Yes, I went to a Royal Sheet Metal we use right next door here, and when I got here, after working here 3 years in the evening, they had started SolidWorks for a year, and the parts weren't coming in right, so they asked me to figure it out and fix it. So I went to the laser house, and I said, I want you to laser cut me a part this size, exactly that size. I want you to put a bend in it. I don't care what it is on both sides. And they did that. So I knew what the blank size was. Then I went to our granite table and got calipers and height gauges, and I measured the exact profile of what the finished part was. I modeled up that profile exactly with a proper inside radius. Then I told it to flatten, and if it didn't match what I told them to laser cut it to, I kept changing the K factor until it matched. Because then I know this is my tooling, this is what I get off that tooling. If I change the tooling, I'm going to get a different answer.
Okay. Because I know a lot of people use 0.5.
0.5 is what they were using here. It's a SolidWorks default from the factory, but it'll probably give you parts that are too big.
Well, it depends what machines are on how hard they're hitting.
It depends what they're using for tooling. But we customize it to the tooling that they make our parts off from. And it's well enough that, I don't know, we probably get a couple $100,000 worth of parts from them every year for all of our equipment, and we no longer QC them. They ship them to us and we put them in inventory. Okay. We set up an arrangement with them that if they miss a countersink or something like that, we'll fix it ourselves and we won't back charge them. But if there's a part that's bent wrong, then, you know, they'll give us a new one the next day. And we don't want to wait around for it. So it saves them money by not having to rework. It saves us money by not having to ship them back and forth and re-inspect them. Because sometimes it's just quicker to stick the countersink on ourselves. And then we get really good service on parts that we can't repair. But it's a, you know, also on the, you know, I said I strip the drawings of information I don't need. So if this is practical sheet metal, the information I don't need is dimensions. Tell me where holes are and what size they are. Because the first thing they're going to do at their sheet metal place is they're going to strip all those dimensions off so that they can laser cut it. They don't want the stuff on there. So it gets, when the press brake operator has a print in front of him, all those dimensions are in his way of seeing what he really needs. He needs to see how to bend it. The machinery cuts it out so it's going to be right. And he needs to just see the information he needs, which is the bend angle and the length of the bend. And so it's the human part is what he does, and that's the only part that really ever goes wrong. In my 10 years of laser cut parts and my 11 years at Holland Sheet Mill, I probably only got maybe a dozen parts that were laser cut wrong. Something happened to their laser or the metal reliefed as it was cut and it changed dimensions on it. So, you know, I asked them several questions, and one is, do you want the dimensions on for hole size and stuff? Says, no, we assume you drew it to the size you wanted it. So no, do you check any holes? If they have a special tolerance on them, we'll check them, but typically no, we're not going to check them. They are whatever you ask for them to be. So the laser is plus or minus 0.008, and the width of the beam is 8 thousandths. So you're going to get what you're going to get. If you want something other than that, you know, you got to let us know. All of our holes, everything is laser cut. So, you know, if you look at a punched part, sometimes, you know, rounds and corners cost more to punch them, but on a laser, it's viewed as costing less to put fillets and radiuses in, because then the laser doesn't have to come to a complete stop at the corner before it changes direction. It can just slow down based on the, you know, the size of the radius. The larger it is, the faster it'll take the corner. So it's a whole different mindset than 20 years ago or so when it was on a punch press.
Are you typically making the radiuses the thickness material?
We do. We do. I mean, they might not be that when I get it, but when I had to decide how to model it up, they really weren't a radius. They're kind of smashed in the corner and deformed and stuff. So in the end, I just said, okay, I'm just going to call the inside radius a metal thickness, and I'll keep changing the K-factor until my flat pattern gives me my blank, and then it's just modeled up that way. If we look into what we're actually getting out of the gauge table, we're getting the things I said. You know, it looks like a 16 and a small GA because that's what I typed in. It's 0.06 because that's what I typed in, 0.39. But then it adds another feature down here, which if you want that in there, that's you just pick something. But to me, that's not the best auto relief. If you're all already familiar with sheet metal, to me the best auto relief, if I go to add a flange on, I'm going to assume you don't know this command. This is if I want to add a bend, I'll go to the edge flange or one of the other ones. If I want to add more flat, I'll go to this one. You know, pick a surface I want to add flat on and just add some flat off to the side. And whatever you draw is what you get. If I want to add a bend on it, my favorite is just pick that one. It's going to add a bend on it. And you're looking to select an edge like this edge or that edge. Either one is fine. You pick the back edge, and when the command starts, it'll pop out the back side. But then you can just move your mouse and it'll go a different direction. You pick the front, it pops out the front side. So you can move your mouse and it goes either way. So you go from there to the sketch, just edit the profile, and you can put dimensions on it how you want it, but you can drag this up. And rather than put a cut in it ahead of time and then bend above it, you can just drag it up and put a dimension on it where you want, but then you pick your custom relief down here And the best one from my perspective, the most cosmetically appealing, is the ob round. And you don't use that, you start specifying it yourself. And this is what it's putting in. It's putting in a relief cut right down there. And the best one is the width. You can say it's 30 thousandths, that's this. And the depth is the straight. After it gets past the tangent, it gives you some straight before it takes the curve. The depth is that straight, and I like to set that depth at 0. So it'll give me a minimum cut, because it comes right in, and as soon as it gets to the edge of the tangent, it'll take the circle and come back around. You put 30 thousandths in there, it's the least offensive, or least, it depends if the gaps bother you or not. Here at FOG, all our metal is typically 12 gauge with a number 7 polish on one side and number 4 on the other side, and we don't want to weld it. We just want the mirror look on it, so we want it to look as cosmetically appealing as possible. So we want as thin as possible with a nice radius. Now later on put an 1/8 inch radius on this corner.
What is that feature called?
It was it's right in the bottom. It's a custom relief type. It's looking to relieve the metal here as you put it out. See, before you know what it is, you'll go in here and you'll put that little relief in yourself. Then you click the top edge to put your bend down so it's all in the right spot. But you don't need to. It's going to put it in automatically. But if you use that feature from here, this is the relief type. If you say ob round, which is a nice one, and we go in here, I don't click custom relief. I just let it be ob round. Then it's not going to be what I want. I can't control this. I can't control its diameter. But even if it's ob round in the default, I'm still going to go in here and I'm going to say custom relief, and I'm going to uncheck this ratio, and then I'm going to specify the 2 numbers.
Then you can shorten.
Yeah, one of them. Well, we can make this 0.12. You can see it gets big. You can make this 1 inch, and if that's what you want, then that's what you get. But I like it 30 thousandths. Laser can handle 30 thousandths. I like 0, and I get a very nice looking part. And when I worked for Mike Fogg, he asked me to design the enclosure for him, so I designed it. And after it was all built, he asked me to come in and put it together, so I came in to put it together, and the first thing he does is he hands me a file and says, go take all the burrs off. So you go spend hours and hours down there taking all the burrs off. Then I went home and got out all my drawings and put 1/8 inch radiuses on every corner there was. And for 12 gauge, you put an 1/8 inch radius on. It comes off the laser and you really can't see the radius, but when you rub your thumb across it, it's no longer sharp. And technically, even though it's small, it's faster for the laser to take a corner with the radius on than it is to go to a dead stop and change directions. So go for it, make it look nice. Because our machinery, we put our machinery out in a plant that fills bottles. It's pretty dark and dungy. But ours, we light it up and it's mirror stands. It stands out like a sore thumb. It's part of what the appeal of the equipment is, not just simply its function, but also the cosmetics on it. And it's enjoyable to see what you can do to make your parts look really nice. So that's one way. If in the putting on that flange, you decide you want more than one flange, technically you can grab more edges. Then if you want to edit the profiles of them, you click the one that you want to edit, and then this will take you off to the sketch of that one. If I get this out of my way. And I can do what I want. It has relationships on it. It says vertical. If I decide I don't want that vertical, I'll delete the relationship and I'll make it into something else, whatever I want it to be. I think I can even put a hole in it. If I say finish, there's the hole in it. So I can do whatever I want with that flange when I put it on. The only problem is if you put 2 or 3 on at once, it'll miter the corners nice for you, but if you want one of them less than 90 degrees, the other one's 90, I don't believe there's a way to control each one individually. So if I put them on one at a time, I can control that angle individually through each command. So there's advantages and disadvantages. It looks like a smaller feature tree, but there's also less control over it. So that's one way of putting a bend on. I'm going to change the shape. I'm going to change the shape. Another way is if this edge here has multiple contours, if it goes up, then over, then up, you can actually pick the front surface, if you will, and pick a miter bend. It goes perpendicular to it, and then you can draw your bends on it. You can say, I'm going to come out there, then I want to do this, then I want to do that. And it'll take that profile and it'll bring it out for you. If you want to wrap that around the corner, you can pick the back edge one up. It'll miter the back side for you. So typically that's what you want to do it for, is if you have complicated shapes and you go around the corner, you'll pick that. But another wonderful feature is if you have more than one shape and you know exactly what it is, how far over you're going, how far up, you can put them all in at once. The only thing you really need to do that I didn't do is, rather than start like this, you can see what happens when you start like that. It really didn't follow it. See, there's my sketch line. Well, that's a lot of stuff that's turned on. You really didn't follow that first one, so then on the first one, if you really want to do it differently, you really want to come down and put the actual radius in, make it tangent to that, and you want to specify it as whatever your radius is. Like mine is 60 thousandths. When you do that, then whatever you drew, you can see it in there. Whatever you drew follows the line that you drew perfectly.
But you put your 60 thousandths radius in?
If you just start from, I put it in here. I didn't put it in. If you want to, you may, but it goes to the theoretical corner. And here it goes to the theoretical inside corner. But the first one, it doesn't. It likes to take off. So if you put the first radius in, if you're going to extend it beyond that surface, then it'll follow your line perfectly going around. Get that or no? Yeah, okay. So if I look at the flat pattern, find where to flatten it. Edit feature. What you get for a flat pattern is whatever flat surface you have, the flat pattern is exactly the same size as before it was flattened. So this one had a flat surface here followed by a radius one, a flat, radius, flat, and the flat pattern will have the same thing. The flat, it'll have its calculation for the radius, the flat, its calculation here, and so on. And the K factor itself is simple math. In calculating a flat pattern, whatever this is in the formed part, it'll be the same in the flat pattern. And it has to figure out how much metal do I need to bend that. And mathematically, the arc length equals the radius times the angle. So whatever the angle is, if it's 45, then it'll be 45 times pi over 180. That'll give you the angle in radians. And you just got to figure out, you know, what radius do you use? Do you use this radius, or do you use this radius, or do you use one that's somewhere in between? And the goal of the K-factor is to figure the one that's in between. The K-factor can range anyway from 0 to 1, I believe. 0 means don't go down at all. Use that radius. If that's 60 thousandths, you'd use that. If the K-factor is 0.1, it'll go 10% of the way down, and it'll use that radius, which is a longer arc length. If you go halfway down, it'll go halfway and use that radius. So the further you go down, the more material it'll give you for the piece that it's flattening out. And really the only way, from my perspective, to get the right answer is to, again, you know, laser cut some parts, bend them up, and measure what they are, and keep changing the K-factor until it matches what your tooling gave you.
You always use 0.39?
No,
What do you change?
Depends on the machine.
that sheet metal thickness with that tooling that they used. I asked them to give me the tooling you're going to use on 12 gauge and bend it with that. You don't put something strange in. Whatever you typically use, put that in. And that's what I needed to give the right answer. And typically, from my perspective, it's usually about a third. You know, say 33% or 35, somewhere in there. You'll be pretty close to a right answer. From there, you can tweak it in. That's if you use the radius of one metal thickness. Oh, and sometimes we will want to bend in it, but not on the press brake. Sometimes we'll want to roll it. So we want a radius part coming out. So you uncheck the default radius, and say you're going to put it through your rollers and you want a 6-inch radius, and you know, my part disappeared there.
I think like 1 inch. Great.
You want 1 inch? I can go 1 inch. If I want 1 inch, I want it off the part. I can do that, but if I'm going to do that, I need to go change the K-factor, because it's not going to be the same as if you stuck it in with a 16th inch radius. And typically, if I go roll it, I'm going to go closer to 0.5 if I go through my rollers. And if this disappears on you when you change the radius, it's because you don't have enough metal to complete what you asked it to do. I said 90 degrees at 1 inch, but I said my blank is only 1 inch long. I got to make my blank long enough to finish what I asked it to do. And if I could go back down and say 80 degrees or something. As soon as I get below that line, it's going to disappear. So if you're wondering why it's not working for you, you just haven't given it enough metal to do what you asked it to do. So we will frequently, say, put a 12-inch radius in. You know, if we have a part that goes through the rollers, we'll put what we need, then I'll come back and I'll cut off the excess, because it's really hard to guess what you need exactly for the radius to hit the tangent. Just got to make sure it's long enough and cut it off when you're done. Okay. This one I put in just as an experiment to observe what happens when you change the radius. I made this little bracket 2 inches outside by 1 inch outside. Then I put a straight line going across to simulate a flat pattern. So if I have a 60 thousandths radius inside, that leaves me 1.88 of straight, which I have there, 0.88 on the other side, which I have there, and an arc length of 131, which I have there. If I take it, we change my spin box. I take that radius, if I make it larger, say if I make it 0.12, the 2 inches is going to stay what it is, but this is going to shrink by 60 thousandths, so the 188 will become 182, and the 88 here becomes 82. But then my radius arc length increases because I got a larger radius. It's radius times the angle. But what I'm really interested in is what happens to the overall blank size as I change this radius. I'm asking for the same part no matter what. I'm asking for 2 inches by 1 inch. But what happens to my blank size as I change the radius in there? And you can watch if I make my radius larger, I got 2.865. Make it larger, the blank size is going down. And if I make it, obviously if I make it the other way, the blank size will get larger and larger and larger. And the idea is, even though the overall part is the same,
You're decreasing the distance.
I'm cutting the corner, if you will. I say it's like going for a walk. If you go straight down, turn 90 degrees and stay straight across, that's one distance. But if you get halfway and you cut the corner, it's a shorter path. Even though my 2 inches by 1 inch hasn't changed, the larger my radius, the shorter my blank size will be. So you can't just take a blank size and say change the radius and expect to get your part to come out correct. It won't come out correct. I've had people make my parts and come back and tell me my blank size is wrong. You ask them, well, what tooling did you use? And you used a really sharp radius. Well, flatten it back out and use the one you're supposed to. I said, well, your blank size is right. It is what it is. It's pretty straightforward math, and that's really what SolidWorks will do for you. It's just a mathematical equation. It's a straight plus the radius times the angle plus the straight. So if it would be 45 degrees instead of 90, it just, you know, the angle is half, so we'll give you half as much for that section of the blank. I want to go to close corners. And when you're done, you want your part to look really nice. And it doesn't look nice like that. That's my perspective. In FOG's perspective, it doesn't. There's a command up in here called close corner. And you could play with this corner to see what you want it to do. You pick one face and the other self-populates. If that's the look you want, and that's what you select. It's other options to change to close it off like this, or a weld corner like that, and it'll make the corner, you know, very nice for you. Closes it right up. If you want to weld it, you weld it. If not, then we typically don't weld ours because we want the stainless to not have the burn marks on it.
So you leave it open?
We close it up tight like that, and we leave it.
Like that? Where
You know, like, yeah, like, you know, we would,
where it said close corner, where they're just tangent on the inside?
you know, well, that's not a good one, but that is what we do. We bring them close. I'm trying to show the various features of it here. Open bend region. I don't want the open bend region. If I don't want it, then it closes it up for me. So there's other features inside of this closed corner that will give you various looks. And you really, you know, the coplanar face means it's looking on here. Are there two faces that are the same distance apart? If so, it'll snag them both when you go to close it. Even though I only selected this one here, it's blue. I didn't select that one, but because I picked coplanar, it'll grab the other face and close it up also. And then you have, what is,
Flatten that. What's your corner look like in that inside?
flatten all these.
Yeah. You're finished right there. That's not bad look for cutting.
What's that?
That's not bad look for cut.
It's not. Typically when I go in here, I'll go in and I'll put an 1/8" radius on there and an 1/8" radius on there. It's just like, you know, it's our product is in the food industry, and we don't want anybody scratching themselves or anything, no blood on our product. So every corner there is, we'll go and put an 1/8" radius on. One of our products is a rinser which sprays a peracetic acid inside the bottle and on the outside, and the goal is to make the bottle sterile. That's the goal. The more sterile it is, the longer the shelf life. You know, some of the juices we go up to 120 days on a shelf life for 90 days. Milk, I think, is about 3 weeks. And you know, there's advantages to being extremely clean. There's advantages to having no one scratch themselves. And people pay a lot of money for a piece of machinery that'll give them an extra 30 days of shelf life, because that's all the less product they got to recall and throw away. So we have a high emphasis here. I mean, a high emphasis on the visual qualities. You know, even as the first set of enclosures we did, we put a number 7 on the outside and a 2B on the inside. And the customer didn't like the look of a 2B, because when you touch it, it leaves your fingerprint. So we had to go back and DA the whole inside, and from there on out for the past 13 years, after laser cutting it, we put it through a sander and put a number 4 finish on the back side. So every piece of 12 gauge we have is mirror one side and number 4 the other, just for the cleanliness and the visuals. So the visuals are very important to us.
Will you not pick up a fingerprint on the 12?
On the mirror is okay. The 2B, you touch it, you can wash it, it just doesn't want to come off. It still shows the look. And it had another one here I like a lot. There's I think it's this one.
That's a pretty good. Where they're just tangent on the inside.
This one is a very large radius, and I picked narrow corner. When I picked narrow corner, it filled it in real nice. If I don't pick narrow corner, you can see what it did to it. It's just a different set of math for calculating what their profile should be. It's doing the same thing, it's just, you know, one is a little more fussy than the other, I believe. So they're worth, if you care about the visuals, they're worth playing around with. It's kind of slow. A lot of our parts we will not bend 90 degrees. We'll overbend it by 20 degrees so that water doesn't pool on the top. And when you overbend it by 20 degrees, then also the closed corner gives you sometimes a look like this, which again does not appeal to me. So sometimes you have to go into the model of the flange. I believe it's this one. I go into the model of the flange, and I'll just put a vertical line on it first. If I set that vertical line equal to the metal thickness, then when I close the corner up, it's a much more appealing corner. So you don't just assume that the SolidWorks closed corner features can do everything you want. You might have to play around with your profile first if you want a little better looking part. And that's a common one I use, is that I have to go up one metal thickness. If I didn't do that, if I went up 0.061, you know, it's giving me that funny look again. If I went to 0.059, I bet you it'd give me that funny look again too. Yeah, so I set it right exactly to what the inside radius is, so it stopped right at the tangent. and I get a very, well, that one did. Well, it was giving me a nice one. Doesn't like me at the moment. Undo, undo. But play around. In other words, play around with it. You'll find a way to get what you want it to get. And
I'm just saying, if you like what you have there.
yeah, I'll leave it alone.
I didn't save it. You're okay.
Yep, I didn't save it. And then oh, I'm gonna go the last thing here. For me, what makes for a good drawing is a flat pattern with overall sizes, so they know how big of a piece of metal to put on the laser. You got to tell it the good side up, always the good side up. And the reason the good side up, I'll get you the reason here. The reason the good side up is because that's what your laser bad's going to look like. You don't want to lay your good side on that. So the good side is always up. And if you put the good side down, you probably get your part back from the fab shop bent inside out, because they will put the good side up. And if you forget to do it, they won't see that you put it the wrong way. You know, there's a laser cut. There's a laser table for you. Here's a press brake. See, for us, they put a 30 thousandths urethane over the dies and bend them up so they don't scar up our metal when they put tool marks in it when they bend it up for us. And here, you know, a wide die versus a narrow one down here. It just depends on how thick a metal you're bending up. The thicker the metal, the larger the die they're going to want to use, because if they have to push a 1/4 inch thick material, they're not going to be able to push it down through here. So they're going to have a wider die, and when we have a wider die, that means you have to have, you know, longer flanges. Your flange has to be at least from the center line to this back shelf. The metal has to lay on top of there for when the ram pushes down on it. It needs to support. If you leave it shy here and you push down on it, it'll just slip down into your tooling. So the thinner the metal, the smaller of tool you can use, and the shorter of tab that you can bend onto it. And you can ask your fab shop what's the shortest flange that they can do for each metal thickness. It'll change based on metal thickness. Here's a very deep die. Frequently we will, if we still want something flattened or over 90, they'll just put a regular die in it that you saw before, and they'll bend to 90. Then they'll come in here and push it in deeper to go over 90. If we want it hemmed, they'll go a third time and put flattening dies in it that are just flat like this one here, and then just push it down and squish it the rest of the way. So it's a 3-step process to get it hemmed over, at least on the thicker metals. And whatever radius you want, and just get some bar stock and weld it to a 1/2x4, and they give you the radius you want. But they might not have a problem. You might have a problem with the bottom die, getting something that works.
How much radius do you usually have it over?
What's that?
Fold it back on itself.
Fold it back on itself? How much what?
What's the radius of bend on the bottom of the metal thickness? At least?
No, that's an experimental thing, because they'll bend it with a 1/16 or an 1/8 inch radius, and then they'll overbend it, and then they'll put 2 flat dies in and just squish it, and it turns out to whatever you do. If you got 24 gauge, it'll be next to 0. If you got an 1/8 inch, you're gonna have a teardrop in there. And the rollers too. The K factor on those, I always use 0.5. The Nutrax, is about in the middle, because it doesn't squish it like a press brake would. And the last thing I wanted to show, well, I showed just overall dimensions, what the press brake operator has to do. It's got the angle on there. Maybe one of them will have the radius on it. Your radius 0.11 typical. And you can edit that if you right click and say edit text to the window, you can get it says bend direction, bend angle, bend radius. If you want to put words in there, you can put words in there, but it needs this syntax for, to go find this information from SolidWorks and put it here. And if you laid your flat pattern up here with the wrong side up, there's commands on the, if you pick in that area, there's commands. Here it says flip view. You flip the view, and the part flips around, and all of a sudden this is up and up rather than down and down. You always want to flip it until you get the good side up. And on your part, you want overall lengths and angles, and reconfirm that that's the good side, or the number 7. Finish goes to the outside. And if you have problems with SolidWorks not having a flat pattern for you, say it doesn't have it, it's a derived configuration that goes back and it unsuppresses certain things. But you don't have to make it yourself. You can just say, make me a drawing. Say, make a drawing. No, I don't want to use existing one. If I make a new drawing, I don't care what that is. When I'm in here, if it doesn't show up, you click the part you're on to make sure it's there, then you refresh it. It'll come up with a flat pattern. When it comes up with that flat pattern, if you go back to the model, it'll now have that flat pattern in there. It generates that flat pattern when you go to the drawing and go to the drawing palette. And when it opens up here and there's a flat pattern, then that's when it writes it to the model. You just got to make sure you go back to your model and save it. Sometimes it'll write a second or third flat pattern in there. You got to look in your drawing, see which one you're using, and delete the other two. Delete the other one. Got 1 minute. Last time people complained I went over, so I'm going to be done today. Thank you. Any questions? Feel free to ask. I'm here. No questions. I'm good.